Transforming quadratic relations, the vertex form. Our learning goal today is to determine how the values of a, h, and k in vertex form transform the parent function x squared. Please ensure you have the lesson printout so you can follow along with this video. Recall, there are various forms of quadratic relations, which include the vertex form, which is in the form y is equal to a bracket x minus h close bracket squared plus k. Standard form, which is in the form y is equal to ax squared plus bx plus c. We'll talk about this one a little bit more in the next couple of units. The factored form, y is equal to a bracket x minus s bracket x minus t, and we've already learned about this one. In this unit, we will take a close look at each form and the key information it gives you. First, our focus will be on the vertex form. And let's try writing that out. The form is y is equal to a bracket x minus h squared plus k. Looks complex, but when we break it down, it's really not so bad. In order to truly understand each form, you must first understand the parent function. As you recall, y is equal to x squared. It is the parent graph that gets manipulated, or in other words, transformed to produce a new graph. So let's review the parent graph for a quadratic y is equal to x squared. So if you guys remember the key points, so x and y, the key points that we're always going to look at are -2, -1, 0, 1, and 2 for our x values, and our y values are just going to be those values squared. So 4, 1, 0, 1, and 4. So as I said in our last lesson, we should really memorize these, and it'll help us a lot in graphing things in vertex form. So let's put those points on our graph here, and we'll fill in our parabola. So -2 is 4, -1 is 1, 0 is 0, 1 is 1, and 2 is 4. Now, let's fill in our parabola. There we are. Now let's look at some of its properties. We know because the a value, which is 1, is positive, it opens upwards. The vertex can be found at the coordinate 0, 0. The optimal value is a minimum, it's the lowest number, 0, when x is equal to 0. The axis of symmetry, x is equal to 0. The y-intercept, where it crosses the y-axis, is also 0. And the x-intercept, there's only one where it touches, and it's also 0. So it's x is equal to 0 here, and y is equal to 0 here. So these are all our properties of our basic parent function, y is equal to x squared. Let's discover how it can be transformed and translated into any quadratic relation. So this parent graph, as I just mentioned, can be transformed, or in other words, changed into a new graph by one or more of the following transformations. The first one we'll look at is a translation of k. So the value of k will move our graph up and down. So we'll see how that works. Horizontal translation, H, and this value is also the axis of symmetry, so H is the axis of symmetry. And horizontal translation is moving our graph left and right. A vertical stretch and compression, so we saw these ones yesterday, and we saw it could be reflected if it's negative on the x-axis, which is part 4, reflection on the sine A. So if it's negative, it can be reflected up and down. So it's positive or negative. Negative is reflected on the x-axis. Positive, it just remains opening upward. So now we're going to use Desmos to investigate each transformation individually and then put it all together. The first one we're going to be looking at is a vertical translation. So we're going to go to desmos.com and we're going to type in the general formula and add the slider for the parameter k. And then we're going to check out each of the following equations, and then we're going to change the k value on the slider and see how the graph will respond, and we'll be able to graph it manually here back on our lesson sheet. So let's go to Desmos. And we're just going to click Start Graphing. And from here, we're going to just enter our parent function, y is equal to x squared. And to get the square, we just click the little keyboard down here and press this a squared button. There we see our parent function. And to this, we're going to say plus the value k. Okay, so nothing will show up until we give k a value. So let's go ahead and do that. And we want to see from example A what happens when k is 4. So we're going to click k. And here we see when k is 1. Let's change the parameters from 0, so meaning there's no k, to 4. And we'll see what happens to our graph. Okay, so we're going to click that. And then let's click the slider. Actually, let's zoom in just a little bit so we can see all the numbers here. Let's go down to 0. Okay, so that's like there's no k value. Since k is 0, we can ignore it. And then let's see what happens when we move to 4. We can see it's just moving upwards. And there's that 4. So the graph doesn't stretch or anything. It just moves all the way up here. And the way we describe this is it's translating up 4 units. So the position of all the points are staying the same. They're just moving up 4 units. So how can we show this on our graph? Let's head back to our lesson sheet. Here we are, back at example A. Y is equal to x squared plus 4. So let's graph what we saw in Desmos. We'll start by graphing the parent function. Do you remember the points? When x is equal to negative 2, y is equal to positive 4. When x is equal to negative 1, y is equal to positive 1. X is 0, 0, 1 and 1, and 2 and 4. And we can just draw a parabola here. Now I'm going to switch colors to represent our new one. And what we saw is that all the points just moved up 4 units. So let's start with this unit 1 over here. So we're going to move this up 4 units. 1, 2, 3, 4. There's our new position. This one is going to move up 4 units. 1, 2, 3, 4. 1, 2, 3, 4. Oops, too many. 1, 2, 3, 4. And the last one, 1, 2, 3, 4. So we can see our graph has now moved up. So before moving on, let's just label this. So this one here in blue is y is equal to x squared plus 4. And the one in red, that's just our parent function. And let me label that. So just to be clear, y is equal to x squared. And we can say that there's a translation, a vertical translation up 4 units. So that's how we would describe this. A vertical translation up 4 units. Let's try example B. y is equal to x squared minus 3. Let's go to Desmos and see what happens. So here we are back in Desmos. We just left this k value equaling 4. So now we're going to change the parameters. We're going to click it. And this time we're going to put -3 on this side. And we'll check from 0 to 3. So again, as if there was no k, and then down to -3. So let's see what happens here. Okay, so right now we're at 0. So this is our parent function, and we're going to take the slider, and let's slide it along here. So you can see, oh, there it goes. It's dropping down. And what value is it at? -3. So we see that the whole graph, oops, let's center that again. We can see the whole graph just move down to -3. Ooh, look at it go. Let's record this on our lesson sheets. So here we are with example B. And always we're going to start off with our parent function. So you know -2 is 4, -1 is 1, 0, 0, 1 and 1, 2 and 4. And we'll draw a parabola again right over here. And we saw from Desmos, I'll switch over to blue to do my other function, that this -3 just moves all the points down 3 units. So let's start with this one. We're going to go down 3 units. 1, 2, 3. This one's going to go down 1, 2, 3. 1, 2, 3. 1, 2, 3. And finally 1, 2, 3. And let's draw our new parabola down here. So the relative position of their points are going to stay the same. With this translation, it's just moving up and down on the Cartesian plane here. So before we continue, let's just label these. This will be our y is equal to x squared minus 3. And the red here is going to be our parent function, y is equal to x squared. And so the way we would describe this is a vertical translation down 3 units. So I think we got the hang of this. Let's try one more example, but this time we won't do it in Desmos. We'll just try it straight here. So let's move over here. So example C. And again, let's start by plotting the points of our parent function. -2 and 4, -1 and 1, 0, 0, 1 and 1, 2 and 4. You're getting good at this. So we'll draw our parabola. And we can see -1. So we know that must mean we're just going to move our points down 1 unit. So if it's up here, it's going to go down 1 unit. And this one here is going to go down 1 unit, down 1 unit, down 1 unit, and down 1 unit. Okay, so there's our new function. And again, let's just fill in our parabola. It's going to look something like that. Hopefully yours is a little bit neater. So we can say here, y is equal to x squared minus 1. And let's label the red one as always. This is y is equal to x squared, the parent function. So how would we describe it? How would you describe it? Oh, that's right. A vertical translation down 1 unit. Very good. So I think we got a handle of the value k and what it does. Let's move on. So let's conclude what our k value does. If y is equal to x squared plus k, the relation has been vertically translated k units up if k is greater than 0, or k units down if k is less than 0. Okay, so we're on the second half of the lesson here. So we're going to be talking about horizontal translation H. So again, we're going to use Desmos, and we're going to set this up in Desmos the same way we did with the first one, but this time we're going to change the parameter H and add a slider to that. So I'll meet you in Desmos, and we'll get it set up. Just going to clear our old graph here. We don't need that. And we're going to start a new one. So let's begin. So we know it's y is equal to brackets x minus h, close bracket, and then we're going to click the little keyboard down here and add our squared button. Okay, and again, nothing's going to show up until we add a value for h. And I think in our example, h is equal to 3 for example A for horizontal translation. So let's check it out. So we'll click here, and we're going to say 0 to 3. Okay, so 0 is as if there is no translation, and the 3 will let us know what's happening with it. Okay, so let's go slider to 0. We can see that's our parent function there. And what happens when we slide to a value of 3? Let's take a look. So, ooh, there it goes, on its way. And what value is he sliding towards? Let's take a look. So we can see the points are just relocating. Ooh. And traveling to the right 3 units. Okay, let's go back to our lesson sheet and fill it out. I wonder if any of you guys are actually doing this in Desmos. If you don't do it, it's okay, but you can play around with it yourself. Anyways, let's head back to translation. You see h is actually equal to 3, and so let's take a look at what happens. So again, we're going to start with drawing our parent function. So we know -2, and it's going to be 4, -1 is 1, 0, 0, 1, 1, 2, and 4. Let's draw our parabola. And we saw that all the values moved to the right 3 units. So we're going to do that. So let's start with this one here. We'll go 1, 2, 3. That's 3 units. Then maybe we'll do this one down here. 1, 2, 3. 3 units. We'll do the 0. 1, 2, 3 units. Right on 3. And then this one over here, move it 3 units. 1, 2, 3. And lastly, this one right over here, 1, 2, 3. And there we have our horizontal translation of the parent function. Okay, so this one here, again, we'll label this. Y is equal to x minus 3 squared, and the red is our parent function. Y is equal to x squared. And let's describe what we saw. Okay, we have a little bit of room down here. You can write it on the side if you need more. Okay, so we saw a horizontal translation to the right, 3 units. Okay, so actually, we're going to skip over to example C, and then we'll go back and do example B. So let's try it out. Here we have y is equal to x plus 4, close bracket squared. We're going to check it out in Desmos, and we'll graph it here in just a second. And I'll show you how this is going to work, because this is a little bit different. Because it's -4, to get this to be plus 4, our h is actually going to have to be a negative number. It's going to be a double negative, so -4, which makes it +4. That's how we're going to make it look like the one in our example there. And I'll break it down a little bit more when we get back to our lesson sheet. So we're going to say 0 here and -4 over here. Okay, so you can imagine it's going to be, h is going to be a -4. So you have -4, which is going to make it look like a plus. So hopefully there's no confusion there. So let's begin. Let's begin here. Let's so you can see the whole thing, and ooh, here it is. So I'm sure you can imagine what's going to happen when we slide here to -4. The whole thing's moving. When we slide to -4, you can see the graph is translating to the left 4 units. Can you see that? And now let's go through that up on our lesson sheets, and we're going to put it all together. So let's fill in example C here. We'll start with our parent function, -2 and 4, -1 and 1, 0, 0, 1 and 1, 2 and 4. You know the drill, parabola up. Okay, so now let's translate this, and I'm just going to switch colors here. And just to break that down one more time, so in this form, we know it's x minus h squared, and for it to be plus h, it's going to be x minus 4 squared, and then that's how you would get the x plus 4. Okay, so when you see the plus sign, it means we're moving to the left when it's in this bracket here. So let's move each thing 4 units to the left. So 1, 2, 3, 4. And then we'll move this one down here. 1, 2, 3, 4. 0. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And now we'll draw our new parabola. And always, I'll just label this so you know which one is which. So this is x plus 4 squared. And the red is going to be the parent function. Y is equal to x squared. Okay, so how do we describe this? A horizontal translation to the left 4 units. And now let's just do example B, and since we know how it works, we can just graph it. So again, like always, we'll start with our original parent function. And here. Oh, it's ugly parabola. It's better. And so we know that this -1 is going to be a shift to the right, because h in this case is equal to 1. And so let's do that. Let's move it to the right 1 unit. So everything's just going to move or shift to the right or translate to the right 1 unit. So we'll start with this one to the right 1. This one down here to the right 1, to the right 1, to the right 1, and our last one here to the right 1. There we are. And we can draw our new function. And this is y is equal to x minus 1 squared. And the red, our parent function, y is equal to x squared. And so we can say horizontal translation of 1 unit to the right. Now let's summarize our findings. So in conclusion, if y is equal to x minus h squared, the relation has been horizontally translated, h units right if h is bigger than 0, and h units left if h is less than 0, or if it's a negative number, in other words. Okay, and just be careful with that negative h. And I know a lot of times we see that negative and we automatically think move to the left, but it's going to have that double negative sign, and it's going to look positive when we have to move it to the left. Alrighty, so let's do an example where we combine both a horizontal and a vertical translation. Here we are. Y is equal to bracket x minus 3, close bracket, squared minus 6. Okay, so we know here the h value is equal to 3, and the k value is equal to negative 6. So that means it's translated to the right 3 units. And translated vertically down I'll just say down 6 units. See that negative 6 there? So we're going to go down 6 units. And let's go ahead and try it. Okay, so let's start with our parent function. So we have negative 2 and 4, 1 and 1, 0, 0, 1, 1, and 2 and 4. Here's our parabola. There we are. And now we want to translate it 3 units right and 6 units down. You can do this and draw them each step. So you can do the 3 units right first, and then draw that, and then draw the 3 units down. Or you can do it in one step. It's up to you. I'm going to try it in one step here. And so whatever you're comfortable with. So we're going to go right 3 units and down 6. So let's go 1, 2, 3 units right and down 6. 1, 2, 3, 4, 5, 6. And then let's do this one. Cross 3, 1, 2, 3, and down 6. 1, 2, 3, 4, 5, 6. This one, same thing. 1, 2, 3, and down 6. 1, 2, 3, 4, 5, 6. Take your time. 1, 2, 3, down 1, 2, 3, 4, 5, 6. A clue that you're doing it right. The relative position of these things should be the same. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So everything lines up. And let's draw our new parabola. And there we are. So let's summarize here. The direction of opening, since A is positive, it's just 1, we know it's upward. Okay, the vertex, and the reason why it's called the vertex form is our vertex is equal to h, comma, k. And in this case, our vertex is going to be 3, comma, negative 6. And we can even see that here. If you go negative 3 and negative 6, we see our vertex. So this number here and this number here, h and k, that's our vertex. And in this case, it's going to be a minimum value because it opens up at negative 6 when x is equal to 3. And the h value is also going to be our axis of symmetry. So x is equal to 3. So we got a lot of useful information from this version of the quadratic equation. If you wanted to find the y-intercept, we set x to 0 and solve. Okay, so let's go ahead and do that. It doesn't ask for it this question, but we're going to add it in just in case you are asked it in the homework. So we're going to set x to 0, squared minus 6. And so this is just going to be negative 3 squared minus 6. Negative 3 squared is going to be positive 9 minus 6. In this case, y is equal to 3. So our y-intercept is going to be at x is equal to 0, y is equal to 3. Okay? And it's supposed to be right over here. You can just see how poorly drawn my parabola is. Maybe I could fix it here. So we know the intercept is right over here. And so we can have another point to go through with our parabola. Okay. Again, try being as neat as possible. I think you can do better. Just one thing to note before we leave. When you're doing your translations, always do horizontal first. So left and right. And then you're going to do your vertical. So horizontal first, then vertical. An easy way to remember that is that it's always the x coordinate first and then the y coordinate, horizontal and then the vertical. Okay, so this brings us to the end of the lesson. After this, I have a few more bonus practice questions. You can follow along with me and do them. But if you have a pretty firm grasp of the idea, you can go ahead and start the homework. Again, if you have any questions later on, you could ask me. But that is it. So we can see here we don't have an h value. So we can say h is 0. So I'm just going to type this in 0. And our k value here is -7. So we can put that as our vertex. And we know that it's going to open upward. So it's going to be a minimum value. So min at -7 when x is equal to 0. Just format that there. Okay, and the axis of symmetry is just going to be that h value, and we know that's 0. H is equal to 0, so x is equal to 0 for our axis of symmetry. So let's go ahead and draw that on our little graph here. We'll go pretty quickly. Okay, so we have our regular points, kind of small. So -2 and 4, 1 and 1. Okay, and then we're just going to translate everything down. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. And I missed this one here, but I know it's going to be right there. And we can draw our points, our parabola. So it's going to look something like that. And you can make sure that you have, if you're, you know your vertex where it should be, so you can know where it is on the graph there. So 0 and comma, -7. Let's try the next one. Okay, so we have y is equal to x plus 2 squared, so that's translated left by 2 units. So our h value in this case is equal to -2, so -2. And our y value, since we don't have a k, is going to be 0. Okay, still going to be a minimum because the a value in front is just 1. And it's going to be at 0 when x is equal to -2. Okay. And the axis of symmetry, of course, is going to be x is equal to -2. And let's draw that translation. So again, we'll start off with the apparent graph, -2 and 4, 1, 1, 0, 0, 1, 1, 2, 2. And then we're just going to move everything to the right, to the left too. So 1, 2, 1, 2, 1, 2, 1, 2, and then 1, 2. And then we can draw our parabola. Here we have -2 translated 2 units to the right and then 3 units up. Okay, so we know our h and k in this case is going to be 2 and 3. So h is equal to 2, k is equal to 3. It's still going to be a minimum value. So it's min at 3 when x is equal to our h, which is 2. And our axis of symmetry, x is equal to 2, and let's graph it. So we have to go 2 units right and 3 units up. Okay, so each one we're going to go 2 units right, 1, 2, and then 3 units up. 1, 2, 3. 2 units right, 1, 2, and up 3. 1, 2, 3. It helps sometimes if you're using different color pencils just to make sure everything is separated, the dots. Here, what I'll do is make my dots look a little bit bigger here. So we're going to go across 2 to the right, 1, 2, and then up 3. 1, 2, 3. Same thing for this one, 1, 2, and up 3. 1, 2, 3. And the last one right here, across 2, 1, 2, and up 3. 1, 2, 3. There's our new graph. And we just have one more example here. So it's plus 5, so it's translated left by 5 units and translated vertically down 6 units. So we know our vertex here is going to be -5, comma, -6, because h is equal to -5. Then we can say that's a minimum still, a is positive, at -6 when x is equal to -5. And that means our axis of symmetry is equal to h, which is x is equal to -5. And let's finish this graph off. Okay, so start with the parent function, 4, 1, 2, 1, 4. You get pretty fast at it. And then we're going to go to the left 5 units and down 6. 1, 2, 3, 4, 5, and down 6. 1, 2, 3, 4, 5, 6. So first one, let's do this one. 1, 2, 3, 4, 5, down 6. 1, 2, 3, 4, 5, 6. Let's get the vertex. 1, 2, 3, 4, 5, and down 6. 1, 2, 3, 4, 5, 6. Oh, I made a mistake here. This one should be over here. And this one here to the left. 5, 1, 2, 3, 4, 5, and down 6. 1, 2, 3, 4, 5, 6. There we go. And our last one. 1, 2, 3, 4, 5, and down 6. 1, 2, 3, 4, 5, 6. And if we did everything right, we should see our vertex should be at -5, comma, -6, and it looks good. And that's it. Okay, so we've seen some translation of some points, and there we are.